Now moving to the next bit of concept, adding on to this, there's something called the Chatelier principle. That's the thing about scientists. We are such egoistic people. We always name it after ourselves. Okay, so the principle is saying that if you make a change to a system, then the system will shift the equilibrium toward restoring your to restore the equilibrium. Okay, so you're starting out 10 grams of this, 10 grams of that. Eventually, you end up with the equilibrium constant. Let's say after 30 seconds, you end up with that. Okay, and this means that at equilibrium, you should have 4 grams of this and 16 grams of this, right? That's what we know. Okay, what if we shift this by changing the temperature? So instead of starting out with this much heat, we're adding in more heat. Let's say liquid water or solid water. In order to become liquid water, it have to have heat, isn't it? So if you add, so this process of water liquid becoming water solid is an exothermic reaction, and heat is part of the product. Okay, now you are perturbing this equilibrium by adding more heat. You're making this heat side larger. So what's going to happen? Well, according to Le Chatelier principle, the equilibrium will shift to the other side to restore the equilibrium. So imagine like a person standing over here, and this person started to have more, this side started to become stronger. It's going to push equilibrium to shift over that way, right? So equilibrium will shifting left because you increase the heat. So then it means that your Kc is no longer going to be 1/4. More ice is going to melt because you just added more heat. So over the time, this will no longer be the case. You're going to have more ice melting, equilibrium shifting more to the left. Your Kc is going to get smaller, and it could get, depending on how much heat are you putting in, maybe it will come down to 1/10 or 1/20, whatever, a smaller. Kc would become smaller. Kc is product divided by reactant. So that's Le Chatelier principle. Turn out the only time that Kc changes is when you change temperature, when you're adding heat. All the other time, you will shift the equilibrium, but you will not change the equilibrium constant. I'm going to show you here in a second. Let's say same reaction. Water liquid becoming water solid. Okay. Kc at that temperature was 1/4 at temperature T. Okay. Let's say you added a tons of liquid water. You added 100 grams of liquid water and 0 gram of water solid. But you are keeping the temperature the same, meaning you're having the same amount of energy in this box that you have in this isolated box. Well, which way is the equilibrium going to shift? Well, obviously, that's 1/4. That's not 1/4. You just added a bunch of this, right? So this guy is really strong. It's pushing that way. So equilibrium is shifting right. Equilibrium will continue to shift right until you get to 20 grams of ice and 80 grams of water. So this is 0 second. This is at, I don't know, equilibrium. Equilibrium time. You're going to have that. And then, so let's say this is 1 hour. I'm going to make some up sometime. 1 hour. The liquid water is going to become ice. And then at this point, your Q is equal to Kc. So if you waited another hour to 2 hours, how much liquid water are you going to have? Well, you're going to have exactly the same. You're going to have 80 grams of liquid water and 20 grams of ice because you have reached that Kc, that 1/4 ratio. Okay? You didn't change the temperature. That's the reaction that you're going to get. Okay, let's say, what if at this time, at this 1 hour time, I mess the reaction have come down to 80 grams of liquid water and 20 grams of ice. What if I add plus, I added 20 grams of ice. Well, if I added 20 grams of ice, obviously my Q is now bigger than the Kc. It's no longer at equilibrium. I just messed up this equilibrium. So then, according to the Le Chatelier principle, my equilibrium is going to have to be shift toward the psi in order to restore this equilibrium. Then some of that 20 grams of ice that I've just added is going to shift left and become liquid. And at the end of it, I'm going to have maybe 25 grams of ice and 100 grams of water. At 2 hours, I'm going to reach the equilibrium again. And I will have, oops, didn't mean to cross that. So at 2 hours, the equilibrium will shift to the left until I get my Q equal to my Kc again. And so that is the Le Chatelier principle. The equilibrium will shift toward the direction in order to restore the equilibrium.